Thank you, ma'am, for your informative and insightful session. Now it is time where we extend our heartfelt gratitude to our esteemed keynote speaker for their enlightening insights and invaluable contribution to today's first session. Now it is time where I would request respected Professor Srinivas Sethi sir to felicitate Dr. Urmila A. Patil ma'am. Please, sir. Now I request Professor Srinivas Sethi sir to continue the next session of the day. Please, sir.
Once again, I request Mr. Sandeep Kanam, CEO and founder of Heatloop. He is the CEO and founder of Heatloop, the machine learning expert training in robotic at Carnegie Mellon University, has worked as on the numerous project, real-time project at the intersection of machine learning and healthcare, education, agriculture. Was featured in Force 2021 list for healthcare systems. He has guest lecture at CMU, Stanford, EPTA, and his writing has appeared in Quartz, Fast Companies, Fierce Healthcare. He is also co-founder of Abdi's and founder chairman of Conam Foundations. Sir, please uh, present these topics. Okay, and students enjoy these sessions. And if you have any discussion at the end, you can ask.
Hello, everyone. A very good morning to all the participants and attendants at this conference, the fourth conference on machine learning, IoT, data. Which means of healthcare. Over the I've had the privilege of being from the very intersection in terms of the applications that are part of both imaging landscape and also at the intersection of NLP and machine vision and all those kinds of things in terms of trying to see how machine learning and AI can really help and empower patients and doctors. To begin with, I've had the opportunity to work with doctors and researchers from Harvard Medical School on helping low vision patients using computer vision. And the use case of how do we help people with limited vision? So they cannot see, they can see something, but they do not clearly see all the colors and contours of the scene. So Google Glass and computer vision technologies that enhance the contours and edges to ensure that low vision patients can also perceive the surroundings around them. So this is but even prior to that, I was engaged in using medical image processing technologies to help with glaucoma detection. Because I don't know if you're aware, but in Indian landscape, glaucoma is a leading cause of blindness. And what that means is people if they're not able to get treated earlier, if they're not able to get detected earlier, it can cause blindness to them. So we were able to use computer vision and medical image processing technologies to see can we detect this early on using retinal fundus images. So that's what you see on the right hand side in the orange reddish color, where we actually detect those colors and then measure the CDR, measure the CAR, and some of those metrics automatically. Now, what large scale telescreening, large scale screening of people who have these conditions, and we can really use technology to create a level playing field here. And there is one more use case, and actually quickly grab my system. Okay, I think I'll just use those slides there. And you also see one more use case there in terms of detecting cancer biomarkers using also computer vision. And this was a project done in collaboration with the University of Nebraska Lincoln researchers. So the common line across these three use cases is how do we deploy computer vision to help in healthcare. Now, after I to pursue my master's in robotics, I had the privilege of collaborating with some of the best minds and also learning from some of the best researchers and professors in the field of AI, learning, and robotics. And I spent a significant amount of my time during my second year of my master's to build a clinical trial matching tool for cancer patients. And this was inspired from my grandmom surviving breast cancer, and I thought I could do something using my newly learned skills to help cancer community. So we went ahead, used NLP at its core to help cancer patients to clinical trials. It saves so much time for clinicians, and also it helps patients get better treatment recommendations. So this is one of the use case where we were trying to build this company, this product, and this is received from all the patients. And application is that there is a huge challenge in terms of patients in the US, and it applies even to India, where they don't have access to all of their healthcare data, right? Data is a huge, huge challenge because they might get this in pieces in some papers, in some emails, and all these scattered applications. But if a patient really wants to use their data to benefit from it, they cannot really do it. So availability was a huge challenge, even in an advanced country like US, because I think around 2008, administration spent billions of dollars trying to digitize health records in the US. But what it did is it actually digitized the health records, but systems, not the patients. So all electronic health record systems turn into systems for reimbursement, for insurance claims and all those kinds of things, but they're not being used to advance and empower patients. So that's one lesson in terms of despite the infrastructure being there, despite these pipes and data items and cloud everything being there, what matters is that data is really available for patients and benefit in care journey at the end of the day. So we have things, and then we built a new company named Upbridge. So at Upbridge, the thesis was healthcare is all driven by spoken conversations. And what that means is, if you think of it as a patient, when you go to see a doctor, first you have a conversation with the doctor, where the doctor asks you about your symptoms, then the doctor diagnoses, and then they give you the medications, and then they give you the treatment plan. And hence the care journey begins. So what we realize is that patients don't capture these conversations, right? It's not usual for us to just walk into a clinic, bring out our phones and record that conversation. That's not usual behavior. What usually is at the end of that conversation, doctor scribbles something on a notepad and then he gives that data. And that is what we call health data. And that is what US government spent billions of dollars trying to digitize. But that doesn't cover everything that was discussed. That doesn't cover the symptoms, past medical history, all the nuanced conversation that unfolds in that conversation. So then we thought, why don't we just empower patients to capture their own conversations? Why do they have to rely on systems for the health data? Because it's their health data after all. So that is kind of a huge revelation in that we need not build health IT systems, because all of you, if you want to do healthcare stuff, if you want to use machine learning, you think of natural language processing, you think of clinical text, you think of data that's coming after this conversation. But we were like, let's swim upstream. Let's help capture those very conversations that are at the core of the care journey. Because now think of those, if you capture those conversations, if you capture every conversation that you have with your doctor, essentially you've captured all the journey. And captured it, you own it. And then you get empowered from it. So that simple intuition of can we really use the spoken conversations to transform and disrupt healthcare for patients and doctors. And so this is hypothesis, because one of the huge challenges that we had at that point is to record, because those are your private communications where you're really sharing your most private and sensitive information with your doctor. So are you really comfortable in the conversation? And it wasn't clear. So we had this hypothesis, we tested around it, we built an application. And I think what we did is we've built enough of a compelling value where we were able to help patients with recording conversations. Then we would transcribe it. Then we would extract all the critical and relevant information from those conversations. And then we were able to provide enough value that patients wanted to record those conversations. So huge tipping point in terms of what it meant, in terms of being able to introduce almost this new kind of healthcare data, which is doctor-patient conversations, and then use that to advance their healthcare journeys. But to give value to patients and doctors, we had to first transcribe it, we had to first summarize it, information extracted, and all those kinds of things using machine learning and deep learning. And this was a company that we started in 2018. So it's been 6 years at this point. And we were using all kinds of transformers, LLMs, and all this cutting edge tech that people talk about currently. So we've been building generative AI product companies much before the term and the product is in vogue right now in the market. But if you think of those conversations, those spoken conversations, they are not clean signals, right? You might have the recording in your pocket, you might have the device wherever it is, and sometimes what happens is when two people talk, right? I'm sure most of you might have interacted with Google Assistant or Siri or one of these Alexa-like devices where you're talking to the machine. And when you talk to the machine, what happens is if it responds well, then thumbs up. If it doesn't, you repeat. You keep repeating until you get the right side or the weather past, all those kinds of things. And if it's still not responding, then you give up. Right? But what's happening in this setting is we're helping patients and doctors capture passive conversations. So we're not interacting with the device as such. And we want it to be an ambient recording kind of app where we are not coming in between. We are not in between where a doctor is saying, hey, Abridge, record this. Hey, Abridge, do this. Because there are people who try to do that as well. But we didn't want to interfere in the conversation itself. We want to be in the background, and we want to be in the background and then help patients and doctors. Now, what that means is from a signal standpoint, it's two people talking to each other sometimes. There are broken utterances. When we speak, those are not grammatically formed sentences all the time, because sometimes we break them. Sometimes people interrupt and we speak over each other. And we are using both domain knowledge and colloquial language. In this case, proper terms, maybe medical terms. And patients were describing their pain and symptoms in very colloquial language. So we have all those kinds of things. And what this boils down to is it's a human-to-human conversation understanding challenge. So that's the first challenges that we undertook. And when we undertook the challenge, the first step was, okay, before we do these NLP tasks, before we do this information extraction task, we need to first transcribe that conversation properly, right? As I said, this is not a setting where people are talking into the device. The signal might not be clean and clear. There could be AC noise in the hospital. There could be all kinds of things that would make transcription challenging. So the very first challenge that we focused on was, can we accurately transcribe that? So if you look at the screen, you see example medical terms were mistranscribed. And that's a huge bummer, because if you mistranscribe the medical terms, then how are you going to extract it? How are you going to provide value to the patients and doctors? So we invested a lot in building a clinical grade medical automatic speech recognition system, first of its kind, where it understands the context. So this is an example. You see Google ASR system, it's a Google API, that is getting the drug Coumadin transcribed as 3 different words in different contexts. So the same thing, when it is the speech recognition engine, it's not being able to transcribe that medication properly. So we've built a medication technique system that can take this conversation, understand the surrounding context, understand the patient symptoms, and if a patient is a cardiac patient, then we know that they're probably discussing echocardiogram. We know, and all of it is happening automatically. So we were able to leverage the surrounding context intelligently and adapt the output of any ASR system and our in-house ASR system to give nearly accurate medical terminology detection and transcription. Now, what that means is now we can really go after the information extraction and other kinds of complex NLP challenges. So the first step was cracking this medical ASR system. And all the work that I'm talking about, they published at international conferences and papers and patents, and all the papers are publicly available. So in case you're looking to get into this space, in case you're looking to understand the kinds of technologies that we've built, they're all available in the public domain. Now, once we've got neat transcript that has all the medical terms properly transcribed, the first and the next step is, okay, how to classify this conversation? Because when you talk to a doctor, maybe initially they're just greeting you. Maybe towards the end, you're just chit-chatting, right? And somewhere in between, there is the key information. So we need to be able to separate non-clinical information from clinical information. So now that's a classification challenge. So how do we take this transcript that is output of the speech recognition engine, pass that to this classifier, and then get all these labels? So the first thing is a classification challenge. And it's not just about is it clinically relevant or not. Even within clinically relevance, are they discussing medications? Are they discussing past medications? Are they discussing current medications? Are they discussing post-medical history? So we should be able to understand and classify all of those different labels and classes. And more importantly, we also need to understand, is it a doctor speaking or is it a patient speaking? Because that makes a huge difference in terms of how to weigh them appropriately, right? Because, and sometimes in these conversations, if you think of it, if a patient, hey, do you smoke? And patient is not directly saying, I smoke 3 packs a day. The patient would say, not really, but once in a while. And then they would say, like once every night. Okay, now what does that mean for a machine? Do they smoke? And what is the frequency? Now, those kinds of complex challenges that exist in a conversation setting, they may not exist in a dictation or other setting. So in addition to classifying, detecting the speaker labels, we had to then detect all these medical terms, detect things like these frequencies. And that's what you see here. for a medication, for instance, so we are able to detect and understand what medication is being discussed, but also what is the frequency that a doctor is suggesting. Because once we extract that, then we can push recommendations. Once we know that a doctor is prescribing some medications, then we can offer additional value to them, saying that, hey, like, follow this care routine. And we can offer them medication coupons, maybe we can offer them help with appointments. And all of that is possible because we were anchoring on a very upstream signal, that is the spoken conversation between a patient and a doctor. And all of this also leverages lots of deep learning techniques. And if any of you in the audience are learning them, there is NLP techniques, there is BILSTM techniques, and all of them are also, they're all currently in the public domain. And we're able to give a schedule for when the patient should come next into the clinic, and we're able to automatically detect them from the conversation. Now, this example is, if we are able to do this in a very unstructured setting, then this technology also works on clinical notes, which are a lot cleaner, a lot more simpler, and a lot more formatted. So that's the complex challenge that we kind of took on to be able to build these technologies. And these are that you see just a snapshot in terms of that we've published, where you can check out these architectures, we've checked out the pipelines that we've built, you can check out the results in comparison with other approaches, and how we really fare well in terms of what we've built. Now, the final grand challenge that we embarked on is, okay, we can transcribe it, and you might have heard about transcription engines. So we are maybe better than everyone else. Okay, we can do information extraction, we can detect clinical terms, but what is we've got from this very unstructured spoken conversation to a final summary that a doctor would write. Now, when you're dealing with two unstructured, there is an unstructured input in a conversation format, and there is an unstructured output in a soap note format. So even this, now everything that I've discussed in terms of transcription, information extraction, classification, all of that comes together from being able to go from this to this output that is a structured note that a doctor can use. Now, this value is of enormous usage to doctors, because doctors need to spend hours and hours documenting this conversation, because especially in Europe, it works on a reimbursement kind of mechanism where a doctor needs to document everything that they've discussed, all the prescriptions, all the recommendations, all the treatment plans that were given to the patients. Now, we have on research, we've published. Now, this led to is we were able to build a first company, first of its kind company, that was able to serve patients and doctors by anchoring on spoken conversation. And this also opportunity and in your company, we've been at this point, and we're in some challenges. Something that is not existent in a spoken conversation format. And we want to introduce a new and benefit. And the system can just record conversations. Anyone can freely use this technology all the time. And the instruction for revenue model is, for patients, any patient, this technology is free, and doctors pay for it, because they're getting real value out of it, and they're getting so much time savings and cost savings in terms of things. And what we've done in terms of in addition to this, we're currently focusing on trying to see how do we move this very English-centered language modeling, English-centered AI, because a lot of what you see right now in terms of the conversations is around in English, maybe Spanish, maybe Mandarin, but India is such a huge and diverse set of languages. So we are trying to figure out and build Indic speech and language technologies that make some of these very technologies that we've built at our bridge to be accessible across all the low resource languages, all the major spoken languages in the eastern part of the world. And with this company, with GitLoop, we are coming out of stealth this summer, And we are recruiting interns, full-time employees, and we are collaborating with research universities, IIT Hyderabad here in India, IIT Madras. So we are collaborating with lots of leading institutions. So if you're interested in contributing to the AI story in India, so please reach out at san@youtube.me. And more importantly, all of this is in a like focused setting. It's helping doctors, helping patients, but with a very mission-centered kind of mission-centered language model building, mission-centered AI building. So the very same thing we've also extended to the non-profit sector through our education, where we are trying to use AI in education to skill up people in employment, in education, healthcare, and all of those things. And we're currently focused on three active projects on the foundation. The first one is how do we build an intelligent tutoring platform for the Indian landscape so that their learning can accelerate? We are using the same speech technologies that we've built at Upbridge and Heatloop to see can we provide speech to speech impaired people, because now finally speech impaired people can pick a voice and they can communicate using to speech systems. We are trying to bring AI to market farmers, and in fact, when I was coming to Odisha yesterday, I was reminded that almost 4 5 years ago, we worked target and in trying to build AI for like regional farmers, and that's one of the projects that we've done in 2017 in collaboration with CMU. Now, everything that I mentioned, whether it is in healthcare, education, agriculture, water, is the and in terms of building models, researching models, building products that could lead to building companies. And the common line this is that it's enormous opportunity. And as graduating students and as current students, I think you are in an interesting intersection where you come up with your studies, you come up with your graduation, your standpoint and there is so much of technologies of AI. So I'm hoping that some of you at least take up this field of machine learning and AI to contribute to the mission centered to build critically and impactful applications, use cases, more, and then contribute to the broader. So thank you so much. If you have questions, if not, we can come meet up and have a great rest of your day. Thank you so much.
Viewing?
Views.
Viewing?
Views. Thank you, sir, for sharing your experiences and giving views towards the healthcare sector.
To our esteemed keynote speaker, we extend our deepest gratitude for graciously sharing your wisdom, experiences, and visions with us. Your dedication to excellence, tireless pursuit of knowledge, and unwavering commitment to positive change serve as an inspiration to all of us. Now I request Professor Srinivas Sethi sir to felicitate Mr. Sandeep sir.
Once again, thanks to both the speaker. It is both the related to the healthcare. It is highly sensitive and also high level talk, and particularly it is very sensitive in the security issue and all this. So inconsistency and overfitting if it is used in this machine learning, deep learning like that. So it is kind of this global applications and real times requirement. Okay. Thanks to both the speakers once again. Now,
ফেলিসিটেট করবে।
I request the special guest of our event, Mrs. Sandeep. So, come here, please. Please, 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 please. It is a special request from this committee, please. Don't.
Thank you, sir. Now I invite our next session chair, Professor D. Anil Kumar, to follow up the further proceedings, which is to be carried out online. Please, sir.
A very good morning, everyone. Our next keynote speaker happens to be Mrs. Vipahi Usaha. She is currently the director of the Center for International Affairs, Suranari University of Technology, Thailand. She has completed her PhD in electrical engineering from Communications and Signal Processing Group, Department of Electrical and Electronics Engineering, Imperial College, London, UK in 2004. Her research interest includes wireless sensor networks, signal processing, machine learning, Internet of Things, as well as resource allocation in communication networks. She is also a co-research founder and research and development advisor for two innovative health tech research spin-offs from University of Research. She is also working on affordable healthcare and wellness innovations and technology for vulnerable groups such as elderly patients with chronic diseases and their caretakers, as well as the innovations to assist healthcare personnel. So now I request ma'am to kindly start her session. Thank you, ma'am.
Thank you very much. And can anybody, can you hear me
Your
well?
audio is not coming.
Oh,
I believe your mic is off.
can you hear me now?
No, still we can't hear you.
Oh dear. Okay.
I think problem is from your side because I can hear.
Can you hear me, Dr. Kumar?
Yes, I can hear you.
Okay,
think
thank you
problem-
so much. Okay, thank you so much.
Just a moment, ma'am, just a minute.
Thank you.
Ma'am, can you hear us now?
I can hear you fine, but can you hear my voice? Can you
Mine,
hear me? Can you hear me? Hello, test, test.
Yeah, yeah, yes, ma'am, yes, ma'am. We can hear you right now. Thank you,
Excellent.
thank you.
Thank you. If I may I present my screen?
Yes, ma'am, your screen is visible now.
Okay, thank you so much for your kind introduction. I hear a little bit of echo there. I hope it is fine in your room. A very good morning / good afternoon to you all. And my name is Wipu Usaha. I'm the director for the Center for International Affairs at Suratnara University of Technology, Thailand. And today I'm very honored to be your speaker today in my capacity as a researcher and founder for one of the research spin-offs from our university called Suratech. And we are working on a wireless pressure insoles that's embedded in shoes that can be used for a variety of medical applications. So my talk today is about sensor technology and collecting big data and creating a better life. And the sponsors are that we have been receiving range from the Newton Fund of UK to the startup funds from TED Funds, the NSTDA, the National Science and Technology Development Agency, PTT, which is like the main downstream provider of the fuel production in Thailand, the National Research Council in Thailand as well. So just allow me to get you to know a little bit about my university. My university is in Thailand. We're not in Bangkok. We are in the northeastern part of Thailand, which is in the Nakhon Ratchasima, which is around 3 to 4 hours northeast of Bangkok, right here in the small map right here. And so in terms of rankings, we're in the 9th of Thailand in the 1,200 to 1,400 in the recent rankings. In terms of young university rankings by THE, we're the 2nd in Thailand, and Asia University rankings, we're the 6th in Thailand. And in terms of the impact ranking, which is where we are assessed by the Sustainable Development Goals, we're the joint 10th in Thailand, but we're also the top 100 in the world in 4 SDGs, which is SDG 1, no poverty, SDG 2, no hunger, SDG 7, clean energy, and SDG 12, which is responsible consumption and production. So with the upcoming THE Awards Asia that will be happening in the end of this of April, I'm very pleased to inform you that the one of our strengths of the university is about community engagement, and we have been shortlisted from the many universities in Asia in the category for humanities, arts, humanities, and social sciences. And our project is on the Silk digital platform to promote silk production and knowledge sharing. And also we are in the shortlisted in another category in the THE Awards Asia as well, in the category of the outstanding contribution for environmental leadership. And this is where we were jointly with the National Park of Khao Yai in Thailand to launch like the country's first smart nature trail. And this has been promoting tourism, and it helps promote income for the local community, which has been facing the wildlife conflicts issues over the recent years. So we're very anxious about this, but we're very honored to be in this nominated in these categories for our community engagement works. So in terms of our university, we are a medium-sized university of around over 16,000 people, mostly are undergraduates. We have over 800 masters and over 500 PhD students. In terms of the academic staff, we have around 559 academic staffs and just under 900 supporting staffs. We have 249 international members from 18 countries, 199 are international students. We have academic staff, research staffs, and distinguished professors and distinguished scholars as well. So here are some of our recent outcomes for the in terms of research. And so we have like an H5 index of 53 and field citation impact of just under 1 for 0.95. We have 9 academic institutes, which are actually our, schools or faculties, you may call that. And from engineering, science, agriculture, social science, social technology, medicine, nursing, public health, dentistry, digital arts and science. And we have service units such as Development Academy, University Science Park, and university hospitals and high schools as well. We have centers of excellences where we have placed strategic emphasis on certain areas of research that we are strong in. And on the left-hand side here, there are just some of the research innovations that are spun off in terms of commercialization, ranging from agriculture all the way to health science, biodegradable plastics, clean energy, and also environmental innovations. So today I'm here to talk about one of the research innovations, which is in the center here, which is the wireless insoles that we have been developing and commercializing as a spin-off from our university. So the spin-off that I have mentioned is from a spin-off called Suratech, and they are focused on delivering excellent healthcare and predictive analytics and biosensors for better lives. So our vision is to become a leader, a global leader, very ambitious, in healthcare and predictive analysis based on wearable sensors. So this is our these are the two of our main products. So the wireless insoles, you can see it's a sandwich set of sensors based in the middle of the top and bottom cover insoles. These are FSR, force resistance sensors with a flexible circuit here, and it sends the pressure on the insoles from eight sensors on the foot to an app through Bluetooth. So this is the color map, the initial version of the color map, what it looks like through our app. This is called Surasoles. And the other product would be Surapodo, which is a force plate, which is a high resolution force resistance sensors, which we use in conjunction with the Surasoles for certain applications as well. So in terms of applications, Surasoles has been developed for use in terms of sports, such as, detecting the plantar pressure under the feet for runners and also for golf. But today we're going to focus on the medical solutions using our insoles, basically, which is what I'm here to talk about today. So in terms of medical applications for Surasoles, we're tackling 3 main issues, which is among the elderly, which is about fall prediction, not fall detection. So we foresee that fall detection is where the damage has already occurred. So we are trying to move into a more proactive way to prevent those damages by preventing the fall in the first place, by predicting the falls in elderly. So in Thailand, there are about 8.5 million elderly people over 65 already. So one of the first works we'll be talking about is in fall prevention. And the second project I will be talking about is the use of the Surasoles for rehabilitation purposes, whether it be stroke, rehabilitation, Parkinson's, or post-surgery for patients, which take about 300,000 people in Thailand in 2018. And the last application is the classification for diabetic foot patients, which takes around 4.4 million DM patients in Thailand in 2006. So altogether, that's an estimated number of possible beneficiaries of around 13 million people or patients in Thailand. So let's talk about the first one first, the elderly group. So according to the statistics in Thailand, ranging from the 2016 to 2017, there are around over 141, almost 142,000 elderly that have been subject to emergency treatment. So the main injuries in those emergency treatments are occurred from fall, hip fracture, and also head injury. So therefore, we are in our work, we are not focusing on fall detection, which detects after a fall has occurred, but we are focusing on the fall prevention, where the risk of fall can be predicted and prevented by early detection, and also by introducing preventive rehabilitation to prevent those falls from occurring. Okay. So, pardon me for the noise. So in the fall risk assessment in the elderly using serosols, we have been using the serosols to collect data from elderly patients at community centers and hospitals in our partnering university. In the partnering hospitals, we collect them by having them walk, and timing them. Like this is called the time up and go. So we time them, and they would walk for 10 meters and back, and then and sit down. So from this data collection, okay, we would we be able to collect a lot of GIET and what's it called? The COP, the center of pressure data. So this is what it will look like as we walk. So you have the shift of the pressure of data as we walk from the left foot to the right foot, and then from the right foot lifting up and then putting the left foot down. So we have what we call like a butterfly pattern. So this is what it would look like for a normal person. So this is the video of the test. So they would be walking and then going back as we collect the data. Okay. Anyway, yes, so I'm sure you get the picture. So after that, this is what we do. We have cleaned the data, and we have observed that from the trace of the center of pressure, or the COP, from the serosols, we find that most of the people who are in good health, like for example, this upper picture is a normal person's butterfly pattern of a person who is 45 years old. So you can see that the butterfly pattern is quite clear. With he has a very good balance, as the butterfly pattern is crossed at the center of the coordinates at the origin over here, as opposed to the subject down here, which is an elderly person of 75 years old, and you can see that the butterfly pattern is a little bit smudged, and the crossing point of the butterfly pattern over here is it's still it's slightly shifted to the right side, indicating there is like more pressure on the right side rather than the left. So these are the things that we use to capture as features, and we developed a machine learning model. This based on the standard machine learning models, such as decision trees, SVM, and etc. Actually, also together 6 of them, and then we compared among the 6 machine learning algorithms to predict the risk of the falls using the insoles, and we found out that we were able to develop a model with reasonable, accuracy around 76%, with an area under curve score around 82%, sensitivity of 75%, and specification of 76%. So this is collected from around over 1,800 subjects of data points. So that was our work for our the elderly, for fall prediction, the elderly. In our second project for the rehabilitation patients, we are using serosols for studying the gait pattern and the central pressure for patients with Parkinson and stroke diseases. And we have been working with local hospitals to apply the post-stroke rehabilitation. And we have been able to find out that very similar patterns. For the normal subject, you can see a very clearly defined butterfly pattern over here. And this is for a person, who's healthy. As we also collected like the PTI, the pressure time integral of which is the area under the pressure curves on the left foot and the right foot as features as well. And this is the example of the butterfly pattern for a stroke patient. So you see there is a lot of deviation from the normal butterfly pattern, as you can see here. So right now we are trying to collect data to develop some a model to help with the rehabilitation purposes. Pardon me. So to help with the treatment, we developed some mobile application games, as you can see on the screen right now. So the games allow the patients to exercise their balance by using the game to induce movement, like lifting the the left foot or the right foot, and also checking on their cognitive skills. And on the right hand here is an example of the student, a young patient with the cerebral palsy, which is like a disorder of the reflex of the muscles. So she's playing with as our games as well. So we are trying to develop the games as such, so that not only can we detect the balance and abnormal gait, but we can actually try to help treat the such symptoms to improve it. At this point, we are in the process of developing games in order to to be evaluated under the clinical trials at the moment. So we have this particular game, which is the foot lifting, and we also have another game which is like a sort of like a maze, featuring how to get out of the maze by using your balance to move a certain object in the maze, for example. So this is another example of our subject, an elderly subject trying to use the game and for exercise, for rehabilitation purposes. And you can see that she's been getting a lot of support. So before the treatment, her butterfly pattern was like that. Okay, so it wasn't really a butterfly pattern. And then after a consistent treatment, we observed an improvement in her butterfly pattern due to the treatment through the games. So we also tried using the app for walk training after certain surgeries, such as the hip surgery. You can see that. So just to before we start the video, so after surgery, there is an initial period where the patients must get up and try to walk, so that they can have a speedy recovery. But however, when in the process, when they get up to walk, they have to be very careful as to how much weight they're supposed to put down. Okay, so for example, the doctor may say that, okay, at the beginning in week 1, you may only put down like 10% of your weight. So having said that, the patient, would be wondering how much is 10% of his weight. So we use this app, okay, to help evaluate the pressure that is that the patient is bearing on the feet or on the leg that has that needs special attention. So this is a case where with the patient with a hip fracture, where we're using the Serosols with the app to help monitor the weight bearing pressure after the surgery of the hip. So
เพราะฉะนั้นเนี่ยปลายด้านนี้ก็ยังเป็นไม่เป็นสีแดงว่างั้นเถอะนะ
ใช่ครับจริงๆโทษครับถ้าสักประมาณ10ไม่เกิน 10% ของน้ำหนักตัวอยู่แล้ว
อ๋อ
ค
โอ
รับ
เคครับ
So-
อันนี้เราเซตเป็น 25%ไงประมาณนี้แต่ก็
okay.
แล้วใช่ฮะแล้วอันนี้มันก็ขึ้นอยู่กับน้ำหนักที่ผมบอกด้วยไงตอนแรกถ้ากรอกน้ำหนักมากไปเนี่ยมันก็จะ
Okay, so basically what they're doing is that they do not want the weight on the insoles to exceed like 10%. So as you can see, as the patient is walking, there is no indication of or warning of the weight exceeding that particular level. So so this is used, to help monitor the amount of weight that can be put on a particular leg or foot. On the right-hand side, this is a patient. He's actually one of our fellow researchers in the team, and he unfortunately had a herniated disc, which is where on the vertebrae the sort of like the meniscus or the cushion in between the vertebrae has been dislocated, and he had a surgery to fix it, and therefore he's using the Serosols, which is inside his shoes here, to monitor how much weight he's bearing on when he walks. So this is another application that we're using it for. So yeah. Okay. So the patient can actually exercise without being too concerned about how much weight, if he's putting on too much weight on the legs or while walking. So this is one of another application of Serosols. On the third research collaboration project, which is on diabetic foot, which has around 4.4 million patients in Thailand. We have a group of researchers working together with our partners from various hospitals on the plantar pressure distribution and balance measurement by using Serosols and Seropodo. And this, we just have like some numbers as to the number of patients of diabetes worldwide, which is around 425 million people. 3.3 million are in Thailand, and coincidentally around 80 million are in India. This is from our research. So out of these patients, we found out that 85% of these diabetic patients who undergo foot amputation because of the development of some foot ulcer that they had. So a lot of those patients have to have their foot or their leg amputated because of the development of the foot ulcers. 20% of these people have diabetes end up in the hospital, okay, due to foot ulcers. And statistically speaking, that is every 30 seconds, there is a person with diabetes that loses a foot due to amputation. So that is a very scary number. So that is why we picked diabetes as another potential application for the Serosols. So I'm sorry to show you some disturbing pictures in the next couple of slides, but just to understand how the diabetic foot ulcers develop. So due to the developed symptoms, there is reduced blood flow in the veins, and with the reduced blood flow, the nerve have become damaged, and therefore, the diabetic patients do not feel, pain or as much as a normal person would. So when they develop certain ulcers or wounds of the feet. Sometimes they do not feel it. Okay, so these are the potential areas that or harm danger that could happen on the feet, where there could be ulcers, there could the corns, or the extra part of the foot that is extruding through the skin, or the bunion around the toe here, or even ingrown toenails on the top of the foot. Now, underneath the foot, the plantar part, okay, ulcers could also develop where there's a lot of pressure on that and friction happening in that area, or the callus, or even dry or cracked skin. Okay, and these are the 5 stages of the development of the diabetic foot ulcers. And the way the classical way that doctors would detect these damaged nervous system areas is through what we call the monofilament test, where you can see that little white stick there that is used to sort of like jab. It's plastic, so it doesn't go through. So to kind of like press, on each possible area, as I can show you in the next slide. So so these monofilaments, okay, are basically like a small piece of filament that is the doctor used to press, to apply to certain areas that they would usually find the ulcers developed. Okay, so so if the patient can feel the filament, okay, that means that the nervous system is still okay. But if you not feel, then there is something alarming about that area. So these are the potential test sites on the foot that you can see, where the blue areas are the areas where the ulcers often occur, which is around up to 90%. They would find ulcers develop in these areas, and the white ones are other recommended sites for the doctor to check. So sometimes for a patient to come and have this monofilament test done on their feet, it takes quite a while, and sometimes it's too late, and the neuropathy or the damage of the nervous system has already occurred. So if it has occurred, there are costs in terms of the monetary side, and also the social and quality of life side. The cost of amputation is around like $2,300 to $5,500 per time, and there are also indirect, costs for the occurrence for the diabetic foot ulcers, such in terms of like medication and indirect care needed for DFU persons of around over $13,000 US a year. So we are looking into trying to find ways to accurately and timely provide measurements on the foot of a potential diabetic patients, so that we can actually avoid a treatment that is too late, that will cost them in terms of the quality of life and monetary issues. So providing the technology that we developed, which is a Souls technology. So as you know, it's the 4 sensors plus the microcontroller board and Bluetooth and the rechargeable battery, and we are able to monitor the foot pressure distributions and display it on the mobile application. And also the doctor has access to the patient's dashboard from the doctor's desktop as well. So there's a potential use for timely monitoring. So we have used the insoles. I'm sorry for the picture here, but then this is a real patient's development of the foot ulcers. So for the patient that we use is from one of the hospitals or partnered hospitals in the south. So we measure the foot pressure from a diabetic patient, and we use the the gate and the pressure data to look at their the pressure distribution. This is one of the samples of the gate pressure. Sorry, the COP pressure that we have here, and you can see that in terms of the foot pressure, we have found that the areas that have significant pressure increase that we detected from serosols is around the forefoot area, which is over here, and also the midfoot area, which is quite significant. So this is another potential use of the technology. So we also have we are well aware that there are competitors in the field where similar technology has been deployed in the area as shown in here. But then to import this into into the country would be costly, and therefore having the country's own wireless insole technology would be more affordable to the local patients. So yeah, so this is the use of the diabetic pressure insole. So as a result of using these readings or the data collected from the insoles, we're able to monitor areas with high plantar pressures on the foot, and with that data, we are able to use that data to customize or personalize a custom-made insoles and shoes for the patient to relieve the pressure area. And we have one of our partners, which is a local, shoe fabricating company called ICMIB, to use the readings to design the shoes for the patients based on the reading. So the serosols reading in this case is used for offload, relieving the high pressure areas to avoid the development of ulcers in the future. So basically, out of this, we have the static data obtained from the insoles for static pressure distribution, and with the serosols, with the insoles that have the pressure sensors in them, we are able to also monitor the plantar distribution while the patient is walking too. So that gives us a more realistic view of the plantar pressure, and therefore we use that data for ICMIB to customize the products, the shoes and the insoles and other like heel distribution for the patient. So in short, our serosol plate has been used for balancing monitoring. So these are some of the applications that have been used by hospitals through our technology already. So it's very simple to use. It only takes around 30 minutes. The patients would be asked about the history and their preliminary health checkup, and they would do the static test on the Seropodo, which is the static plate, and the dynamic test, which is a walking test. And the data that will be used will be analyzed on the dashboard, and then they will be given the consultants of the physician, and they will be recommended a training program. So this is for the hospitals that have been using our technology. It can also be used for gait monitoring. So for those with with maybe runners or even people who have trouble, walking or aches with their legs, knees from prolonged standing. So serosols can be used to monitor their gait. This is only the test is only like 15 minutes long. We use the Seropodo for static pressure distribution along with a dynamic pressure distribution. So with this, the cause of the pain, okay, in terms of pressure can be detected, can be visualized, and then the insoles for that particular patient can be suggested based on the plantar distribution. So similar outcomes with that would be a given report from our app, a consultancy, and then support of the arc and the foot to alleviate those pains. So we also have because monitoring of gait and balance or even rehabilitation is a timely process. So if the patient has to come to do these services in front of a specialized, a technician or the doctor, every now and then it would waste a lot of time. So we have developed like a Sorosols telemedicine as well. So we have like the Sorosols in conjunction with a developed app that we use to create like a face-to-face contact with the technicians or the doctor with the shared data from the cloud. So that would be saving time and also allow the doctor to treat more patients than before. So it's a win-win situation. So as I said earlier, the diabetic foot is also one of the applications of Sorosols. So this is basically to detect the plantar pressure, and it's only takes 15 minutes. So the patient is asked for the history and preliminary health questioning, and also doing the static test on the Soropodo, the force plate, and the Sorotols for the walk test, and the plantar pressure is analyzed along with the report, the consultancy, and the support of the arc of the foot, and also training programs, etc. Here, as I said earlier, we have a rehabilitation, which is also can make use of the Sorosols plus the telemedicine as well. And so basically, we have been able to have like clients from several hospitals to use our technology, and they found it to be fast and easy, using like 10 minutes to analyze through the standard procedures like standing and then walking on the treadmill, and then analyzing the data based on the dashboard. And so this is what our dashboard looks like. And so we have like the COP, the center of pressure, and the PTI, the pressure time integral of the gaits, and the color maps, and also we also have it supported on a website, not just the mobile application for report analysis as well. So these are the summary of the features that we have done so far. So we do the diabetes, the rehabs, and then for sports as well. So this is basically what we offer to the hospitals in terms of the services that we provide for each particular target group, which the hospital aims to support. So these are our hospitals. So we've been working closely with the 5 hospitals to collect data and develop the model that was used to develop the apps. And these are our research partners throughout the country. So we have like affiliated hospitals, and we have universities, and also partners from the industry to help assess and customize the required treatment that is needed to help those patients. And this is our multidisciplinary team. This is the last slide already, and you can see that we're from myself. I'm from telecommunication engineering. My colleague is from material side, and we have like from the business side, we have a material scientist. We have people from the sports side, the medical side, the orthopedics. And this is my PhD student. He's our data scientist already. And we have like engineers, and a marketing officer. So this is, I think that concludes my talk. I hope I have not been over time. Thank you.
Yeah. Thank you, ma'am. Thank you for giving an insight into the healthcare.
Yeah, can I come in a bit?
Yes.
Hello.
Hello. Yes.
Yes, sir.
Yeah, Dr. Upay, this is Udgata.
Hello. Yes.
Hello. Are you able to hear me?
Yes, I can hear you. Yes.
Yeah. How are you?
I'm very good. Thank you.
You are doing good, actually. Good to see you. Thank you very much for accepting our invitation. And
Thank
I
you
know,
very much.
yeah. I will get back to you again. And this is too good, actually. I mean, it's very good. And I am aware of the work that you do and all that. And our participants also enjoyed it quite a lot. And thank you very much for accepting our invitation and gracing this conference, actually. We would like
Thank
to
you.
see you in. We would like to see you physically in some other versions, actually, maybe next year. Maybe next
Thank you
year or
very
next year.
Thank you.
Yeah,
I will
yeah,
try my best to be there, Professor Shiba.
Yeah.
And thank you for having me on your conference. Thank you so much.
Yeah. Thank you very much, actually. In fact, yeah. Over to you, Dr. Sir.
Thank you, sir. Just a minute. So our next keynote speaker happens to be Dr. Sachin Kumar. He is a professor and leading researcher in Big Data and Machine Learning Lab of South Ural State University, Russian Federation. And also he is a research advisory member of Department of Computer Science, GIET University. He has completed his PhD from IIT Roorkee in 2017. His research interest includes recommendation systems, natural language processing, supply chain management, health information. He is also a professional member of IEEE, International Association of Engineers, Institute of Research Engineers and Doctors, and ACM. He is also an editor and review member of so many reputed international journals. So now I request Sachin sir to kindly start his session. Thank you, sir.
All right. Am I audible?
Yes, sir. Yes, you're audible, sir.
All right. Thank you so much for having me as a keynote speaker. So as we are limited with the time, so I will make a quick start. Okay, so please confirm if my slides are visible.
Sir, not yet. Yeah, it's coming, sir. It's coming. Yes,
All right.
visible now, sir.
Okay, all right. So my talk is about multimodal learning for lung cancer survival prediction.
Sir, sorry to interrupt you. Can you just maximize it? Full screen, sir, please.
Yeah, it is full screen in my computer.
Sir, share entire screen will be there.
All right, let me check.
Or you can do slideshow. That will maximize automatically.
Is it working now?
Sir, you can press F5.
I think there is some issue when I'm pressing F5, which is restarting the system.
No problem, sir. You can share it again. We'll manage.
Is it clear now?
Yes, sir. It's okay now. Fine, sir. Fine.
All right.
Yes, sir.
So
Thank
the
you, sir.
title is about multimodal learning for lung cancer survival prediction. As we all know that in general, we have AI for medical healthcare. Basically, we are trying to make classification based on the medical images only. That is just X-ray, lung cancer X-rays or brain tumor CT scans. But now in this study, we are trying to capture not only one modality, but the two. So let's try to start. So lung cancer, as we all know, is one of the leading cancer killer in both man and woman in the world. And that represents from 19.4% to 27% of all deaths among other cancers. And lung cancer can be broadly classified into two categories. The first is non-small cell lung cancer. That counts for 85% of the cancer. Another is small cell lung cancer, SCLC. That counts for 15%. And both of these have very poor prognosis. Moreover, the 5-year survival rate of lung cancer is lower than many other leading cancers, such as colorectal cancer, breast cancer, and prostate cancer. And more than half of the people with lung cancer die within first year of being diagnosed. Therefore, accurate assessment of this disease stage and the survival time of lung cancer patient is very essential in deciding the optimal plan and time treatment for the clinicians. And nowadays, a large fraction of interpretation of medical information is performed by the doctors. And in terms of image interpretations by experts, a lot of diagnostic errors appear in radiology. And approximately 20 million radiology experts contain clinical significant errors every year. And this limitation is mainly due to the subjectivity, the fatigue of the expert, the complexity of the image, as well as the extensive variations across different interpreters. Moreover, 2/3 of the world population lacks adequate access to these radiology specialists, and this would translate to 4.7 billion people, which is a huge amount. AI, as we all know, is a very promising tool in healthcare for diagnostic purposes. With the rapid development in deep learning-based computer vision techniques such as convolutional neural networks, the ability to recognize images or diagnose images even exceeds the human ability. More specifically, it enables computer vision models to assist the doctors to detect suspicious pulmonary nodules or identify the location of the nodule and evaluate whole lung pulmonary malignancy and predict the risks of lung cancer. Even in some cases, it is found that models have reached competitive performance to doctors, and the accuracy even exceeds sometimes to the doctors. However, in most of the cases, a simple X-ray image, CT scan is not enough to diagnose the disease itself. And a doctor has to consider other variants such as medical history of patients, blood tests, clinical data, physical health reports, etc. And all these types of resources about the patient's information is different, and hence they are called different modalities. Combining these modalities together in the data set to accurately diagnose the medical disease using AI is a challenging task. In this study, we are attempting to develop a multimodal fusion approach to diagnose lung cancer using both clinical and 3D CT scan images. The dataset that have been used in this study is obtained from TCIA, that is the Cancer Imaging Archive, and it considers 422 non-small cell lung cancer patients. For these patients in the dataset, CT scan is available. That is manually delineation by a radiation oncologist of the 3D volume of the gross tumor volume is available along with the clinical outcome. The patients who had neither survival time nor event status were excluded from this work. This is the basic notations that we have used in the study. That RI, that represents the ith 3D radiology image. CI is the ith clinical information. YI is the actual value. Y hat is the predicted value. EI is the ith event, and its value is 1 for uncensored data and 0 for censored patients, that is incomplete information. IX is the one if X is true, else 0. I want to explain here about censored and uncensored. Censored patient, that is incomplete information. That is about those patients who got healthy or they stopped the treatment in between, and we do not have the data about if they were alive or survived or dead. That's why the incomplete information, and we call them censored. Now, multimodal deep learning. Multimodal deep learning is the novel framework that uses deep learning to learn from multiple modalities, such as text, images, audio, and video. In medical applications, multiple types of data can be related to each patient. That includes clinical information, radiology images, physician notes, medication, and etc. Therefore, when data comes from different sources, the approach of multimodal deep learning can help to understand and extract more useful information that may provide more accurate diagnosis. 3D Resonate is one of the popular deep learning approach, and we have used this because it can handle gradient vanishing or exploding problems in deeper neural networks training, especially in field of computer vision. The core concept of ResNet is to construct a basic network block in which the output adds up with input. To handle 3D image input, we can simply increase the kernel size from 2 dimensions to 3 dimensions that will consider height, length, and depth in convolutional layers. The survival analysis is the widely used technique to analyze time to event data. Some of the examples are student dropout, cancer survival, admission to hospital, disease recurrences, etc. We have several traditional statistical methods for survival analysis that can be non-parametric or parametric methods. The parametric methods are Cox regression, which is the most commonly applied, and distribution predefined, such as linear regression and Weibull distribution. So due to the existence of censored survival data, usually right censored, the standard evaluation indexes for regression, such as mean square error and R square, do not fit for quantifying the performance of survival analysis. Therefore, the most important evaluation index is C index, that is also called concordance index, which can evaluate uncensored instances and censored instances together. The formula is mentioned there. And besides, as a regression problem, we also use the mean absolute error over only uncensored instances to evaluate our experiments. So this is the proposed framework. Here you can see on the top left corner that we have several screening methods by which we can collect the information about medical patient. It can be medical history and physical exams, several kind of ultrasounds, some biopsies, magnetic resonance imaging, and computer tomography. So one modality we have chosen as an image that is taken from computer tomography scan, and other methods are medical basic biopsy, histology, age, clinical TNM stage, overall stage, and the gender of the patient. Here TNM stage is simply when the patients were admitted. TNM represents what was the stage of his cancer. Maybe it was the early stage or late stage or intermediate stage, similarly. So for medical clinical records, we simply used simple neural network to extract the features. And for medical images, we have used 3D ResNet for extracting features. And you can simply say we have simply concatenated these features together. And then a neural network is trained to make the prediction. So we can study them in detail now. So CT image feature extraction with 3D ResNet. To eliminate the vanishing and exploiting gradient types of problems in the very deep neural network, the extra shortcuts connections in our model were used. Since data set is relatively small compared to other general image data sets, we use data augmentation techniques before importing the data into the model. For clinical record feature extraction, the clinical embedding layers introduced clinical data to the network separately. And for this, we used a neural network with 2 hidden layers to extract the features. Since the features, the number of inputs were very limited, that's why a simple neural network can perform this task. For the future fusion stage, multimodal features taken from CT images and clinical records, they are difficult to be directly fused together because they have different scales, properties. Therefore, to solve this problem, a batch normalization techniques, a Z-score normalization, is used on the extracted features. And the formula, it is its usual Z-score formula is given. For survival analysis, to meet the requirements for a specific problem, any survival model can be used, as we know that we have Cox regression and other methods. But in this work, we define the survival time as the label and use the 1 hidden layer neural network with 1 dimension output layer for the regression setting and overall optimization convenience. To achieve the same scale between the ground truth and the output in our model, the sigmoid function is used as the normalization technique to process the output. And mean squared error loss function and L2 regularization penalty term as the objective function is used, which is defined. We conducted then extensive experiments based on non-small cell lung cancer patients from DCIA to validate the performance of the proposed method with other state-of-the-art methods in terms of the prediction accuracy of the survival time for each patient. Besides this, we also evaluated the prediction result by C-index. Afterward, we performed several ablation experiments regarding different network structures to determine the best structure to achieve the best accuracy. Data pre-processing, like we had CT images and we resized the raw data, which is the 3D volume of the primary gross tumor volume, into 9:6 into 9:6 into 8 resolution. And after that, we transformed the range linearity into 0:1. Then to prevent the overfitting, we performed data augmentation that includes 3 methods: rotate, swap, and flip. And then we got around 422 into 8, 3376 samples, among which there were 2,984 uncensored samples and 392 censored samples. In data pre-processing for clinical data, as clinical data contains both categorical and non-categorical data, therefore, missing value is a common issue in medical data and may pose certain difficulties for analysis and modeling. In this data set, the age category contained a few missing values. So we had carefully observed this age category, and it was found that age of the patients in the data set is quite close to each other. Thus, the mean value is inputted and filled into the missing values to handle this. Further, to fit into the model, one hot encoder to encode categorical data into numbers is used, which allows the representation of categorical data to be more expressive. And then we use the min-max feature scaling and standard score method to perform the data normalization, such as age and survival time. So for input X, the min-max feature scaling methods output is a general formula that we use all the time. And the standard Z-score method is also the same. We trained, during the experiments, we trained and evaluated the methods on NSELC radiomic datasets following 5 cross validation with the patient levels. Thus, we divided the dataset into training, validation, and testing data into 6 to 2 respectively. For hyperparameters tuning such as penalty coefficient, we used the validation dataset to fine-tune and get the optimized hyperparameters. In the training process, 200 epochs in total were used with Adam Optimizer. The batch size was set as 64. The initial learning rate was 0.001. And then learning rate is decayed by 0.5 in every 40 echoes. Since we use survival time as the label, not cumulative hazard, in the training and validation process, we only use the uncensored data for precise survival time and objective function calculation. Further, in the testing process, we use all data for C-index evaluation and uncensored data for mean error MAE evaluation. Then ablation study was performed, And the goal of ablation study is to know the following questions: how the depth of ResNet affect the performance, which 3D structure is the best, whether multiple modalities outperform single modality, what is the best ratio set between image data and clinical data in the fusion stage, and whether hidden layers should be added in the survival analysis stage or not. So to get answers to all these questions, the ablation study was performed. So firstly, the evaluation of different depths of ResNet and whether multiple modalities are better than single modalities are conducted. By using one hidden layer in the survival analysis network and fixing the ratio of multiple modalities features in the fusion stage to 512 by 27, 4 different structures were tested. Table shows that our model of ResNet 34 structure with multiple modalities achieved the best performance, and all experimental results support our assumption and show the effectiveness of using modalities in survival analysis. In the table, you can see that we have tried several ResNet structures for feature extraction, that is ResNet 18, 34, 50, 101, but the ResNet 34 obtained the best results for multimodality, the minimum loss and maximum C index. Further, using the best structure that are ResNet 34, we step further to observe the effects of changing the ratio between modalities with and without the hidden layer. It can be just changed by the number of perceptron for image and non-image features. The comparison results list in table show that setting the ratio between images and non-image modality as 25 by 27 achieves the best performance. Besides, adding hidden layers in the survival analysis module can further improve the performance. The table shows the first column represents the ratio of image and clinical features. So as we can see that 25 by 27 receives the best result. It simply indicates that the features, when the features are biased, the results are not good. But when 25-27 is approximately same ratio, so we had the best results here. And we used for survival analysis, the neural network with no hidden layer and with one hidden layer. And with one hidden layer, we have the better results. So for survival analysis, we fixed our ratio 25-27 with one hidden layer neural network. And after these experiments, the best architecture of using ResNet 34, the best ratio 25 by 27 with one hidden layer was compared with other parametric and non-parametric methods which are available in the literature. And we found that our model outperformed the others baselines. You can see here MAE for only uncensored data and C index for both censored index and uncensored data is outperforming the other models. Further, to improve this one, because here we simply used clinical features and image features and we are just combining them together. But now we have other module available that we know as transformer, which are very important nowadays. So we just improved our network by using a transformer module between the features and the prediction module. So instead of combining these features at early fusion stage, we provided these features separately in the cross model in transformer module, which try to learn the relationship between these features and then provide a fused features to the prediction model. And then we compared our results using transformer and without transformer and with other baseline models. So here we can see second column represents the model which we proposed already without any transformer and the results achieved, and then improved model with transformers. Here we can check and see that for every model, the results were improved after using the transformer module. And still in our case, like proposed model, which we proposed and using transformer, it is still outperforming the other existing non-parametric and parametric survival modules. The summary in brief, like lung cancer survival module has been developed using deep learning on multimodal data. Separate models were trained for clinical and 3D chest X-ray image data. Then for clinical data, a neural network with 2 hidden layers is used, whereas for image data, different ResNet architectures is used for feature extraction. Ablation study then performed to identify the best ResNet architecture that we found ResNet 34 for feature extraction, and then best ratio for clinical and image features were obtained, 25/27. And then best neural network architecture for survival prediction module was identified. And further experiments were performed using best combinations, and that model outperformed the baseline models. Besides this, a transformer module is added as a fusion module, and then our results even exceeds the previous accuracy. So this was all done from my side. Now questions are welcome.
So thank you so much, sir, for your wonderful presentation. Any questions from audience?
Sachin, I have one not questions actually, just comment that can you please elaborate, like how did you validate? Actually, you mentioned somehow, but what kind of, you have like 422 total NLS data sets. So do you think that the size of the data is okay to get if you use, for example, for other data sets, how validates that?
Actually, you are right, and I already mentioned that the data set is very small comparative to other. And since the concept of multimodal deep learning in medical data is still new, so we are trying to get the data where more information is available. So we were targeting the lung cancer, and we only found out this data. So we tried to do some experiments to identify if this methods is working or not, because medical data is more complex than other data that is available in other domain. So it was like an attempt to get the insight if we are doing right or not. And now we have other data also, but it is like quite big, and it is having a lot of diseases. And when you are combining data from different diseases, you cannot target the one. So we are still filtering out, preparing the data from that data to further test this approach and develop the new one. So you are right, the data is not suitable, but still it was just used for the make a try.
Thank you, Sachin. Thanks.
Thank you.
So any more queries from any of the audience? Okay. Thank you, sir.
Thank you so much.
So now our next and last speaker of the day is Dr. Rajiv Kant, who is working as a principal lecturer at the IT department of Savonia University of Applied Sciences, Finland. He received his Doctor of Science in Information and Communication Technology from the University of Turku in 2013. His current research interests include energy-efficient wireless communication architecture for sensor networks, IoT platforms for healthcare, and food supply chain applications, and artificial intelligence. He has published more than 45 scientific articles in peer-reviewed conference proceedings and referred journals in the field of computer science and communication technology. He has been a member of IEEE Communication Society, IEEE Cloud Computing Community, IEEE Earth Observation Community, and Green ICT Community. So now I welcome Dr. Rajiv, sir. Kindly start your session. Sir, can you hear us? We can't hear you, sir.
Can you hear me now?
Yeah, yes, sir. You're properly audible.
Yeah. So
thank you, sir.
Can you see my screen also?
Yeah, it's on the way.
Okay, perfect. So just a moment, I will share my screen once again. So is it okay? Can you see it now?
Yes, sir. Yes, sir. You're visible now.
Okay. So thank you very much for providing and having me in this last actually keynote session today at this 4th International Conference on Machine Learning, IoT, and Big Data. I remember that I had attended in person last year this with Professor Srinivas and Professor L.M. Patnaik. So today I'm going to talk on this Internet of Things, sensor technologies, 5G and AI research at Savonia University, which we are taking care at Savonia. My name is Rajiv Kant. I did my, like I can say here, so I'm like living in Kuopio, Finland, here nearby. So I did my PhD from University of Turku, Finland in 2013. And then I had a chance to do my postdoctoral research at KTH Stockholm in Sweden. I lived there and I again came back to Turku as a senior research positions also and senior research. Currently, I have also a position at University of Turku where I am a senior research fellow there. I have been living in Finland since the last 15 years, I would say. And I have more than 25 years of teaching and research experiences. So first of all, I will tell you a little bit about this Finland. Probably you know. So Sauna and Angry Birds game, probably you know. Santa Claus, one of the popular destination in the Rovaniemi, which is situated like about 500 kilometers from my place here. I think recently this is one of the happiest country in the world. This is the UN report, and I think last couple of days ago it has been again seventh times actually it's the happiest country. I would say that I belong from different parts of the world living here, and I see that innovation actually is one of the key things in Nordics, particularly not only in Finland but also Sweden, Norway, and Denmark. Here, education systems also pretty good. So this is the place where I am.
Sorry to interrupt you, sir. Have you shared your screen? It's not visible. Kindly share your screen, sir.
Okay, so just a moment. Give me a moment. So. Can you see it now?
Not yet, sir. Yes, sir, it's on the way. Yes, sir, we can see it now. Thank you.
Yeah, sorry for that. So I think I was here first. So I was talking about this. Can you see it now?
Yes, sir. Yes, sir.
Yeah, so these are the things I talked about, one of the Sauna and Angry Birds and so on. So let's move further a little bit where I am residing actually. So this is a Kuopio, which is like from Helsinki, approximately 450 kilometers. And from Turku also like 500 kilometers in the north side. So Kuopio is I would say it's a lakeland, and it's you can see there lots of, it looks like an island, lots of water and lakes are here in the winter. Now we have already, you see, I think still it looks like similar one. So you see this Puyen Tower from here, and Puyen Tower, my house is almost 2 kilometers from this in the west side actually. So the talk today, I'm going to particularly in the Savonia education strategy, and then I will be talking a little bit on our current research, what we are carrying out, my team also, and also particularly I will be focusing on this one Business Finland project, which we currently have. And that project is critical infrastructures, like cybersecurity solutions for the critical infrastructures. We have two entities, like Smart Water Lab and Smart Factories. I have been teaching sensor technology several years. I will be talking a little bit on this big issue, cybersecurity solutions, particularly in IT and OT technology. And then we have developed and did some experiments on this open platform communication unified architecture, and that we have implemented both in our Smart Water Lab and also Smart Factory. And we are currently working with bigger players in the world, like F-Secure, one of them, SSH, one partner there, and also Nokia actually. We have also created a small digital twin replica for that. And then this related research on AQSEC and 5G use cases I'll be talking. So first of all, what Savonia is, probably if you see in my Savonia, we have like about more than 800 students. Actually, we have approximately 30K alumni. We have this business partners a lot across the globe, is approximately 2,300. Our graduates actually get employed, and this number is quite high, 90% actually. You see, our university have like plus 600 employees, and we annually produce like RDI volume approximately that's 14 million euro. Our turnover is 59 million euro, and what the key thing is that we have students remaining in the area. So the idea is that we are focusing on more applied research, applied educations, and skills-based educations where students retain in this area. We call it Savo area. So it's like, I would say, central and eastern part of Finland. So students remain and do their research and education and develop in that particular area. So let's go further. We have been focusing particularly on this 4 things here: values, choices, policy, and vision. So if you see, to be the most vision is Savonia 2030. Vision is to be the most socially and responsible and influential university of applied sciences. Here, if you see at Finland, we have 2 classes of university. One, we call it classical or science university, whereas we have another university which we call it University of Applied Science, where we focus more on experiential learning, particularly. For example, how students would really get benefit with their skills actually, and how those skills would be quickly implemented in the society. That's the key idea actually. And then we have you see, code development with RDI activities. We have Savilahti hub, we call it. It's like a smart hub, we call it, more than like all the bigger universities, applied science universities, vocational schools, and also over 150 IT companies actually across in our campus already. We focusing more internationality, and Finnish government has pushing a little bit more on internationality, and the number of international students have been increasing day by day. Our choices, particularly on personalized education, demand-based continuous learning, mission-based RDI business activity, expertise, and its visibility particularly. And then we focus on reliability, courage, and the community spirit. So this is the Savonia strategy 2021 to 2030. So one of the method that we use in our education is like CDIO. We call it conceive, design, implement, and operate. So this means that I would say it's a project-based learning, I would say. And we focus also on OIS, open innovation space. For example, we focus more on innovation. We have at Savonia this bachelor degree program in Internet of Things, where I am leading in our program at Savonia, and we focus on this innovation particularly. So it's a problem-based learning, social and team work skills. Students would get acquire deep engineering competences. We have state-of-the-art facilities for IoT, particularly in embedded computing sites, cybersecurity solution sites, also cloud engineering sites, and also artificial intelligence. So we focus more on this, and these students who are graduating, actually, they are the workforce for the future IoT ecosystems. As I said, innovations and skills to the labor market through the applied sciences. So we are serving the enterprises and the working life by developing new knowledge, new products and services. We have been heavily working with companies here, and lots of research is going on with different, as I mentioned, it's a big volume of RDI activities, new working processes, new ways to develop skills, training, and entrepreneurship in the workplace. Every University of Applied Science has defined 4 focus area of RDI. Students are also involved as like internships, or they do their final thesis or final projects, for example. And participation of teachers connected to RDI teaching and education is much higher, actually, I would say. RDI and education complements each other. This is one of the video actually where my students were working on in 2020. Actually, this is the 2020 batch. So these are some students, and we have some students from India as well. For example, some students you can see from Ireland. This guy is from Estonia. This guy is from UK, from Arabian, and then Russia. So like there is some video. I'm not going to play that video. Also Ghana also. So this we have in one class, it's a multicultural students, more than 21 countries students. So class atmosphere is quite good, approximately 40 students in a class. So let's go further. These are some of the pictures you can see with our students. This is one of the events that happened 1 year ago, where we have this super ecosystem week. Actually, some students, this guy has recently graduated and he has done quite good job with me. Also, he is still in the graduation. This is orthotopinen actually. So there are some. So we are focusing particularly on this Savonia IoT studies, 2 areas particularly. In one area, we are focusing on digital health, where I am involved in master degree in digital health, actually, one of the program which we are running. And then we also have this industrial IoT, focusing more on industrial IoT, where we talk more on this 5G communication platform, clouds, and digital twin technology. I will be talking a little bit about digital twin technology that we build and implement for our smart factory and also for our water lab. These 3, ERP, MES, and PLM, probably you know this. These are the things where this kind of this is part of OT systems, I would say, operational technology systems. Then we have in digital health sites, we are trying to get more connected with the healthcare industries. We have so many projects also with Kuopio Hospital, where we have recently, I think, done one research on eye modeling actually for this ophthalmologists, and then also with the neonatal cardial analysis actually with the deep learning, what Sachin was talking earlier. This I will talk a little bit about these activities which we have been carrying out now here. So you see we have this factory. This is from actually this is Festo factory, but in our lab actually we have Lukas Nulle from Germany, where we have this Siemens MindSphere, edge computing, and 5G technology. These are the NR new radios of 5G, which we got from one of the project from Nokia. This is a small glimpse of our water lab actually, where you see. So these like ERP, MES, and PLM particularly. So the part of we have lots of research going on also on this robotics side, simulation, modeling, and digital twin particularly. So let's go one step further. This is the picture of the water lab which you see here. So lots of research in this side. If you see, lots of sensors are here, and this area is particularly this water tank. We have been doing the downward is chemistry and biological research is going on, whereas at the top level here, we have the data visualization, also OPC UA, security things, cyber security solutions actually we are creating and implementing with those sensors data which we are collecting in real time every now and then. As I mentioned to you, I would like to show you this video particularly. This is one of the model of Savonia Smart Factory, where you see this is the, I would say it's a demo. So this means that these are the devices came from the ERP side. So this means the ERP meaning that the users or the vendors actually order, for example, this, and this has been prepared. These are the stocks, for example, say 2 complete parts here, and there is for example, bolts here. So they are collected, and it has like PLC, Siemens PLC, programmable logic controller, where it's the controls of this movement. And we try to, maybe I can show you this video, probably you can see it. So I will stop here. The idea is that how we could optimize the process, for example, how we could do the resource optimizations, how we could do, how we could enhance the efficiency and availability of the machines, particularly. These are the open questions, and we are working on that. So one of the key thing is that, first of all, we need to have one model, or the digital model, for this entire factory. We are creating this already, and we are in I would say that we are already in a position now to connect this with the digital replica. You can see this student, one of the students from France, has built this, and they have this is the pure replica, but there are different parts here. He put it differently. This ABB robot earlier we have, and then also we use this human being. So you can see this is the part actually, and this is created in visual components. One of the very well-known, I would say, modeling tool. So this modeling tool, so this is the white one and black one, and then we later on also figure it out how could be the efficiency and productivity could be enhanced particularly. So these are the things, and what are the parameters that it depends on. If we speed, and so how it affects the entire factory, actually its efficiency and so on. So I think in this video there are also, I don't know if there are some videos. This is a little bit earlier video, but now we have done also this getting the performance and all the charts and all the analysis already. I don't know if this video has, I think so. Let's go a little bit further. So let's come to a little bit on this sensor technology, which is my expertise area. I have been working very highly with different sensors, and you know that sensors are one of the key components for complete IoT. If you don't have, and then you need to understand how data could be collected in real time from different sensors, particularly, and how you could store the data, how you could filter the data, how you could pre-process those data. So I have been working at some of my papers also on this human presence detection with Omron sensors earlier. So, and then also we are working on smart irrigation systems, lots of other temperature, pressure, flow, pH, gas sensors, vibrations, accelerometers, and radars. Recently, we have done one also this LIDAR data analysis as well. This is one of the key things that we are working on. All the things which you see here, students have built from their own design with the SolidWorks and created in our 3D printing facilities. We have very good 3D printing facilities in central Finland, I would say, and I see that it's even biggest 3D printing facilities. So students have opportunity to model and get the new things actually. This video I would like to show you where we little bit use about this AI aspect. So you can see here. So I will explain a little bit here. So in the workplace of this robot, particularly you have wing nuts and also the bolt. And the idea is that this robot, how it could recognize what kind of objects in there. So there downwards there is a camera, and this camera says that okay, this is wing nut and this is bolt, for example. We also tried with this a plain bolt, not threaded bolt, but there was some issues due to the computational complexity, but this model is working quite well. So the idea here is this model is stopped here because it does not pick this bolt, because this robot has been given instruction or configured in such a way that they only collect the wing nuts from the workplaces, and this has lots of potentials in factory environment if you need sorting, for example. So one of our students group did that. Maybe we can. So it stops now. It doesn't pick this bolt also. So this, when it says that it's a bolt, so it. Okay, so let's go further. This is, I think I don't go. There are several robot related projects we have been doing. So we go a little bit further. Now, if you see, this is a little bit about this embedded computing things, which we are really working on. Some of our students, these are, I think, first year students who are working with this embedded things. We have given them different light emitting diodes, also this surface mount small devices like capacitors or resistors, for example. And they did this actually very well, actually. In the, if you see, this is a, like all the students, they have done from their hands actually, and they give the voltage 5, and it has like triple 5 timer circuit. It's a potentiometer here. This is the two ICs, and the students have done from their scratch. They solder it from the, so this is one of the soldering practices that a student did in their bachelor degree first year analog electronics courses. I have been also working with lots of other researches, for example, drone related works where we have did some of the, you see, this is our home in Finland. And particularly you see now the situation almost the same. We have like approximately 1 feet, probably you can see the snow. The question is that how you would know in real time the snow depth on your roof or the mountains. And we have done some experiments using this ST microelectronics nucleus 64 microcontroller, which are fitted there. And we did it, which is also published here. So this is one of the, and we got very accurate result actually. And we are doing lots of other research related to drones and this embedded computing. Let's move further a little bit. This is one of this OPC UA server client architecture that our current students have been utilizing. One of this is like the 3 parts actually. One is the visualization, OPC UA client and OPC UA server. Here we can see that this back of PLCs, we fetch the data from there. There are controller computers, and then we have this OPC UA client particularly. And you see there are 2 units, 2 clients particularly. So this is our recent client server architecture using OPC UA. So here we realize this in terms of like process, which is one company actually, they have built their own. And then also this OPC process, OPC UA historian, we also did with Node.js and also UA expert. So different methods, it's visualized, and this is the architecture. So let's, so this is what we have in OPC. Maybe I will ask, this is one of the video actually made by my students for this digital twin. So this is the main device actually, which we have in our systems from the PLC where we get the data. And this is the main our TwinCat engineering server. And then for OPC UA client, we have used different tools. One of them is UA Expert. Due to this data security thing, we cannot see what kind of data is here. So we cannot see. One of this UA Expert is one of the tools that we have used, and real time we get those data from the sensors, all the sensors. We have approximately 100 sensors, and this is one of the company who is working with us. This is called Process. So we use their tool to get all those data visualized in real time. And then Historian, which has the best capability to like put the data, create the database or store the data, which is one of the key things. And then we also use this Node-RED. So all those temperature values and pressure values in real time, it's visualized. And now we are working on creating an alert system if there are something happened, or if you put some threshold and get the value if there is something happening. So this is the, I think, the flow level. This is the flow level. And lastly, this is, I think, the pH values of these data. So, okay, let's go move further a little bit. So this is the plan. What is the main ideas? Actually, we see that IT and OTs are one of the key components. And we see that in IT sides, we have already full-fledged kind of security solutions. But when we add those with this OT, for example, then attackers or like the intruders, for example, try to get data because we don't have. So we are working in that direction as well with this Business Finland project. Maybe. Okay, and then I think there are two more things remaining in my presentation, which is this 5G network. As I mentioned, we have this 5G, our own private network, which was developed in last year, actually, from Nokia with one digital transformation with the regional funding funds, which is EU funding. We have approximately, like you see, 11 radios on that particular N258. And then also N257, 2 radios. So approximately we have 15 radios altogether. And then also sub-6 gigahertz in our Savonia's healthcare and IoT labs. Actually, we are using N77 or N78 actually. This is some of the devices we have been recently bought. We have not worked on these devices, but these devices are helping us to get more, because leaping towards the quantum, or for example, we are talking about more speed, for example. So of course, this 5G millimeter wave and these devices which currently we have not yet worked, but recently I think in February, all things have been installed in our lab. This is our Savonia AI server, also upcoming NVIDIA based AI platform. We had big discussions whether we should go with AMD, NVIDIA or Intel, but we choose NVIDIA for this, and we have this already now in our systems. Now, I will be talking a little bit with some of the projects that I am contributing particularly. So this is one of the projects where my role is one of the work package leader. And here my work is sensors and AI particularly. So this is automation and artificial intelligence digitization project. This project has started actually last year in April, but usually we started our work from September. This project will be ending in 31 March. It's a Innovation Finland Action Projects. And the idea is developing companies, technological know-how, business opportunities, and we have the budget of approximately 420K euros. 12 regional companies are also involved, and it is supported by Finland EU regional funds. Then this is one of the key projects that I am currently leading. I am the PI for this project also. AQSEC, we call it AI-based quantum safe cybersecurity automation or orchestration for edge intelligence in future networks. So we have two universities. One is Jyväskylä University of Applied Science, who is the leader, and then we are from the Applied Science University. Savonia is one of them. And then we have Nokia, Process, as I said you, SSH. I think Rellers has left, but Spectra and Goodmill Wills also we have. Recently, we had the steering committee meeting also. So this project will be ending. And for this project, one good thing from the India perspective, I would say that I have recruited one person, postdoc, for this project. Probably he has already presented this morning one talk, who is like working on more on AI aspects. So particularly here, our role is to use this IT and OT syncing issues, how to get this cybersecurity solution, particularly in IoT OT syncing connections. And then this is another project which has been ended last year, I think end of last year, December, I think 2023. It's really very good project actually, and we have 4 academic institutions, like Denmark was one, Germany, we have one, Karvensule. Karvensule is a great nearby this Mercedes-Benz in Rastatt. And also in Finland, we have 2 universities. One is Savonia and another is Ylä-Savon Ammattiopisto actually. The idea of this project is to create the course module for a smart factory particularly. So we have designed different modules, and our modules were data collection and analysis, and then data-driven manufacturing. These 2 work packages we were working on, whereas Danish partners and German partners particularly, they worked on this digital twin issues and also industry 4.0 concepts. And Denmark was working with particularly on this collaborative robots. Actually, we call it cobots. And one of our Finnish partners, they are working with AR VR technology, and we have done. If you are interested with this project, just this is velifact.eu, vlefact.eu. If you write velifactory.eu, if you write, you will get more information on there. This is a little bit earlier project that we did. We are heavily also working with this drone things. From it has started, I think, in November 2019 and June 2023. So we created like model for the university carry out research and education on unmanned aircraft systems. This is one of the key things. One of our article has been presented, like what are the things Finland needs now, in which particular area operator side, for example, or the researcher side, what are the needs? So that we have studied in this project. And I was the project manager for this project. This is one of the videos I would love to show you, where we have done. I think this is interesting and pure AI thing, where we use this latency and communication speed, where we compare the Wi-Fi versus 4G advanced and Wi-Fi versus 5G network. And this has really put lots of good attention to the nearby companies. For example, one of the bigger companies in our Nordic area is IKEA probably. They have huge, and they have been interested working with this. So I would like to show you where we have compared and see how latency and the speed of the communication effects, and we use the robot. We use particularly here reinforcement learning. So let's see. So probably you see that the latency data that we have this LiDAR sensor here, it creates the point cloud, and from that point cloud, we use the model. And this student which you saw there, he is doing thesis along with me now already. So he has been doing, and we see that these kind of things is very important, and latency or the speed is very important. So I think this is the last part of my research. So I have been currently working with, as I mentioned, one of this AI research is classification and profiling of the possible threats in the cybersecurity or the critical infrastructure network that we are talking. Some few of my students are also working with Helsinki Port live feed data sets to see the pattern and to see or give the live, for example, pattern of traffic near the port, particularly when we have this Helsinki Port that cruises particularly goes to Estonia or goes to, for example, Stockholm, for example. So how and what kind of traffic pattern when there is any ships are coming there? This would be very good for the Helsinki city to know the live pattern actually when there are any ships or any passenger cruise are coming. I have been also worked on lots of earlier synthetic data generation algorithm. You can see some of my students have worked, and we also, for example, we discussed with the Sachin paper, the data sets issue particularly. So I would say that this synthetic data generation method is also one of the key, and you should have some threshold similarity indexing, and how you could validate those synthetic generated data, because now it's a era of image and video generation with synthetically by AI. We know that, so that's also somehow supports if we need larger data sets. Also, different disease classifications and so on. My teams when I am working with. So thank you very much for your attention. If you have any questions, please.
Thank you so much, sir, for your wonderful presentation. I believe we have been exposed to a lot of live projects and based on your 5G, AI, and sensors. Thank you, sir. Any questions from the audience or any online attendees, please? Sir.
Thanks, Professor. It is very interesting presentation. May I know the interface between this 5G with the robotic applications, how it is interface and how it is running through the 5G.
Can you repeat once again?
This, particularly related to this interface with the robotic applications using the 5G. So how 5G will be connected with this robotic, so that robotic can use the cloud data and all other communication information.
So yes, so for example, we get the internet from this Wi-Fi router which we have if we need Wi-Fi in the supporting area. So for 5G also we have this 5G router, 5G access point, which was installed in the antenna, small antenna inside that, and we have this 5G network area was this, and I say N78. This is sub 6 gigahertz. We use that, and from when they get the data, the server has all these point cloud data, and they are computing actually with very high speed, and that's the reason actually they are connected together in real time, and it worked quite well. This was the experiment that we did. It worked quite well.
This extended another question, that is the configuration of this robotic with the 5G? Can I know the how to configure? Or is it plug and play methods to connect with the robot and getting this information from clouds and running it?
Not
is
yet.
it-
Actually, we did not work so far with the cloud, particularly sending the data. But from the server, we collect those data and it computes in the real time.
In terms of the hardware part, how to
I think I don't remember exactly, but it has a very high GPU based high. I don't remember exactly the configuration, but it has very high
yes,
end.
no issue. My thing is that
Yes.
actually 2 of my scholars are working in this area also. That's why I think also this can be extended with our applications. So in future, you just mail me regarding. I also remind you regarding this GPU and all other hardware part and with configuration. Please help me in this regards. Okay.
Yeah, I think we have recently that I showed you in our last. We haven't gone through those new petaflops computing power devices which we recently bought for our AI and 5G integration experimentation and implementation. Particularly, we haven't done, but I see that there are lots of potentials to do really, because now you know, like we are going towards quantum thing now, so it's everything has been changing. So actually we actually in that side we have little bit devices that we could use. Maybe I would love to maybe collaborate also if possible.
Okay, thank you very much. Thank you. We'll discuss in the offline. Thank you very much.
Thank you so much.
So thank you once again, sir.
Thank you.
So we have come to the end of this keynote session for this morning session. And I thank all the students, despite of a Sunday, your support has been really admirable. Thank you so much. So now I request all the faculties and student coordinators to kindly move to the swimming pool for lunch. Students, you can start leaving, please. Thank you.